everybody, and welcome to number 7 of our virtual presentation series, hosted by the WiMAX Forum, during which we invite sort of luminaries in the AeroMax world to talk about their company, their organization, the impact they've had vis-a-vis AeroMax, and to sort of share their insights. Today, we're very, very fortunate to have a long-term friend to AeroMax, Dr. Rafael Pazza from NASA. Give his presentation, and I actually learned a heck of a lot in looking at his presentation before this meeting today. I never knew that AeroMax, the research and development and the thinking around AeroMax actually went so far back, easily 15 years at this point. So it certainly does, and his presentation will make this clear. It does give us a kind of a lot of insight into sort of the deliberation, if you will, that the Federal Aviation Administration, NASA, Eurocontrol, and others took in thinking about sort of the next generation communications platforms for the aviation industry, and specifically the testing and thinking that went into the selection of AeroMax. As I mentioned, I think this is our 7th presentation. We began, it feels like a lifetime ago, where we had the regulators really talk about the rationale and genesis for AeroMax, and that included Eurocontrol, FAA, and ICAO. We then moved to users of the system, a very prominent user of the system in the form of Aviation Data Communications Corporation out of China, the security associated with the system in PKI and certificates with Yanti, and then a prominent manufacturer, namely Siemens. We continued with other users and manufacturers to include Lisbon. They've had a commercial deployment now for 2 years, which they're expanding with AeroMax to a host of applications for Vinci Airport, the Lisbon Airport. Telrad, their supplier, was on the line talking about, sort of what they thought about as they concluded their AeroMax technical profiles and their equipment that they brought to market. And we were delighted to have DigiCert, which is really the guts, if you will, behind our security solution. They are the largest PKI issuer in the world, certificate issuer in the world, and we're just really happy to have them partner with us in terms of delivering PKI to market for AeroMax. Our next presentation, we had Leonardo, a systems engineering company, vendor, equipment manufacturer that would be well known to everyone in the aviation industry. Talked again about their product portfolio for AeroMax, and specifically what they're doing on the European front with Eurocontrol and Cesar, et cetera. We're delighted to have Alok Roy, who is a kind of a wise man in the AeroMax industry. It seems like every time you run into some special committee here and there, Alok Roy is the chair. Certainly his influence on the development of AeroMax can never be overstated. We were also pleased to have Shoichi Hanatani-san, who is a chief advisory engineer from Avicom in Japan, talk about their deployment and their sort of aggressive thinking about AeroMax in the Japanese airport scenario. We in another series we had Leonard Korvacek from Selfplan, which is really a radio planning company, but has done a lot of groundbreaking work on AeroMax radio planning. Talk about the necessity for good radio planning, and also really looking at sort of capacity and cellular planning associated with AeroMax. Had some concrete examples around the world for some analyses that they've done, which was great. PowerTech, which is our lab which tests and certifies manufacturers' products for complying to the international standard, gave us a very good presentation on sort of the genesis of the certification program and the importance of it. And our most recent presentation, virtual presentation, was we were delighted to have another manufacturer vendor in the form of Convergex, which brings devices to market, AeroMax devices. Talked about sort of the form factors and vision for devices, as well as a company called Symantec, which is doing a contract really on behalf of the FAA, looking at sort of wireless best-in-breed practices as wireless standards and wireless technology becomes more and more implicated in the aviation sector, particularly secure, licensed broadband wireless. So obviously AeroMax is part of their analysis. Next slide. Before I introduce Raphael, the real reason for us doing this virtual series, which I think is probably obvious to all of you, is that with the coronavirus and COVID-19, as we began the year, we found our ability to interact with, by and between the ecosystem is pretty hampered. And so we wanted to, there's still good news happening and good work being done and interesting work being done. So we thought at least we could provide a virtual format for members of the community to get together and talk about what they're doing. So, having said all that, let me move on to the more interesting part of the presentation. And Dr. Rapaza, again, a longtime friend to WiMAX, and he's been looking at really the needs for broadband, secure broadband wireless communications in the aviation sector for 20 plus years now. And Raphael, without further ado, I invite you to go ahead and start your presentation.
All right, Declan, yes, thanks very much. It's a pleasure to be here with you and in the WiMAX community. Talk about all the work that's transpired here to get to the point where we are today. In the support that NASA has provided. So NASA started to look into modernizing, CNS, and a few years back. That's in 2004, and actually earlier in 2003. There was a lot of planning to this project called Space-Based Technology. Basically starts to take a look at improving the performance of CNS systems and trying to bring it into a more of a network-centric digital type services and systems to support really what would become the future of the National Airspace System. And that project, I thought it was quite ambitious back then. We had several sub-projects, and I'm listing those there, in which we addressed, integrated CNS infrastructure and their technologies. What those technologies were to be also was investigated, looking to satellite-based CNS. When we were taking a look at the oceanic work in investigation that was taking place back then. Also looked into future communication systems, what the architectures would be, and what those may be, and how they would operate, in the National Airspace System. And within that set of sub-projects, we also have there, and I'm highlighting them in red, the airport surface in terminal airspace communications. As we all know, those are both tightly connected. So that I was fortunate to lead that particular set of activities or tasks. In addition to that, we also had an effort in which we developed a CNS test bed, which is a proving ground facility that has evolved over time. So the work, believe it or not, we had great thrust moving forward with a lot of activities taking place, a lot of exchanges, support from the community, members participating back then, and all was coming together quite nicely. Unfortunately, the project got halted in 2006. However, there was great laid out work in a path forward charted through this initiative, addressing now the work that we did during that period of time on the Airport Surface Communications Project. This predates WiMAX, and this is the first look at what is the possibility to bring out a complete wireless system to the airport surface. So we started the research and development with different initiatives with the look to really transport voice and data communications over one system and serving multiple stakeholders. So back then, we all understood that there was a need to really, land a spectrum band under which we could build a system for airports, airport operations. Back then, I know that there was some, already engagement on behalf of the FAA on the Work 07. We at Glenn put together a campaign to basically validate the performance, and along with characterizing the band, the C band. As you can see in those that black and white chart, it's actually the first measurement campaign that we did for this band for airports. It was done in Cleveland. And actually, to illustrate the actual spots, the measurement spots that we did, this was a partnership with academia. During this effort, we ended up measuring Miami Airport, JFK, a host of medium-sized airports, and some smaller airports as well. And this was, again, in support of both the work and ICAO band deliberations. And at this point, we're focusing on 1591, 5150 megahertz. Along in parallel activities to this, we're also developing the basic concept definition of what a network for an airport should look like. Added to that, we looked into the functional system architecture, of course, and we started to work and look at future concepts and architectures. And what that really means is, up until that point, and still today, the information distribution on the airport surface is kind of separate. You have fixed nodes generating information and sending it to the air traffic control tower, utilizing their own specific systems. Then you have the aircraft or mobile platforms on the airport surface that also have the need for exchange information. So at this point in time, start to take a look at really bringing these different communities and sources of information and integrating them into a larger architectural concept. So moving on with that, we are also taking a look at trying to understand what is really the way to go here. And what we're trying to debate at that time is whether do we want to develop a specific radio system for this environment, or should we go with some standards that have already been proven and developed outside of the aviation forums. So we took a look at back then, Wi-Fi was evaluated, WiMAX or the IEEE standards were looked at, and others. In fact, there were some tests bed of other technologies. Ultimately, we ended up becoming in conversion to the 2016 series. I remember, and I looked this up, by the way, I went in preparation for this, took a look at, so what chipsets, who do we contact? And we did talk to Intel, in fact. Rosendahl chip, we had discussions with Fujitsu, we evaluated Sequence, Telesis, and others. And ultimately, after deliberations, we, internally and externally, we basically decided that data 2016 was a very good candidate for service communications. That took place in about 2005. Along with that, of course, we needed to understand, so how does this all come together, and who is the user of this system? Who are the, who are really going to be putting their services in this type of system to improve their operations and really enhance any airport, large, medium, small, and along, so we understood there was a need to look into the requirements. Back then, we put together a study to investigate Dallas-Fort Worth, and we did accomplish that. And the investigation did not only include, the air traffic system and the technologies that we have there. But it also included the airlines, American Airlines, cargo operations. We also took a look at the Port Authority and try to gather, all these different requirements, but by this community of users. You can also see there's some in 2005, some of the measurements that we did here. We did, that particular picture was taken in Miami, by the way. So now, the other area that I want to mention in here was the use of the test bed. There's two activities that are key to the development of airport wireless communications, and of course later on WiMAX. The test bed came together really in partnership with the community and industry, government, in the form of FAA, and NASA played a big part, and also local government in Cleveland Hopkins Airport also were instrumental in bringing this facility together. Originally, the test bed was made up of 3 airports, and the notion of CNS and how these technologies will come together necessitated that we didn't focus on just one particular location, or for that matter, just surface, because it was also airspace under consideration, both terminal and en route. Remember the dialogue back then, and we have one of the busiest corridors in the en route stage of flight above Cleveland, which is the connection between the New York area and the Chicago area. So those 2 regions fly quite. The airspace above Cleveland is quite heavily used, connecting those 2 major hubs. So there was a great attractiveness, and it was very attractive to bring the test facility to Cleveland and observe and investigate all these different airspaces. As time went by, and the test bed evolved, and we started to realize that, although we were very ambitious in putting together, a facility to address many different circumstances and scenarios, we needed to go ahead and really bring it down to one, which was focusing mainly in Cleveland Hopkins Airport. Of course, we had the controlling facility and other laboratories at the NASA Glenn Research Center, which is adjacent right next to it. The test bed objectives always remain the same. We scale it down. We still have been able to prototype and evaluate the technologies, conducting measurements. Of course, it's always required in the development of any technology. And of course, the risk reduction is one of the key elements of this type of testing facility. We conducted quite a bit of research in surveillance, for instance, and that's basically on surface surveillance. Looked into virtual towers. I remember having a deployment of a virtual tower prototype at testing, as well as later research that addressed Smart NAS, which is a NASA project. Along with, of course, airport wireless communications, and the first test, and later on when we went to really evaluate the WiMAX technology. A lot of frequencies have come and gone. There's a set there of about 10, and we still have some that we every now and then exercise the system, and there's a number of locations distributed throughout the airport, and some of them are at the NASA Glenn facility. Next, please. Continue with the testing and what it looks like. Again, improvements have been made since its first version. You can see the experiment control and monitoring. So we've got a lot of planning has going on in that particular room to take a look at what's going to be the taxi routes, for instance, for when we're testing WiMAX, what radio systems, testing of radio systems in their connectivity right there. Of course, connected to dummy loads, for instance, the radio systems. We've done a lot of work in that room. This particular test facility is given that it has an airport component and it's got the NASA research labs, is accessorized with a microwave system. So over there you can see on the right-hand side we have that network equipment which we're hosting not only the wireless point-to-point microwave system, we also have routing systems and switches to distribute the data to the right computer systems for data recording and data regeneration, for testing of the system. We do have on the right-hand side bottom, we have now and then you can see some of the prototype technologies are still in this picture. You can see the Alvarian system there, like pretty much right below the microwave system. There's also, you can see the antennas for the Hitachi system that we used in there. And we've given this particular location on the airport ground quite a bit of use. We do also have the customer premise equipment, or CPEs, the bottom two sensors located in two different areas, in which we were able to test fixed communications and the performance of the system once you aggregate both fixed and the mobile platform. So when I was talking about the mobile platform, you can see the aeronautical research vehicle at the lower left. It's one of the vehicles we've used other type systems or vehicle systems. So this will enable us to do ground tests, mobile ground tests, and in preparation, for instance, for an actual aircraft testing. And then we have the analysis and evaluation and the WiMAX system. Those two other pictures there. The top one shows, the rack that has different components of the WiMAX system and the AAA server. And this makes up a lot of the components. This is not the whole aspect, but it really illustrates the different systems that we have in the facility. So looking into what did we do in this particular setting and in this particular laboratory? Well, and I'm going to look more now towards the WiMAX testing. In 2010, we started to do the first mobility testing, and you can see that this is the van and the vehicle there, right there by the runway threshold. The two white vehicles where we looked at link stability and throughput rates. It's cyclical, so it's our first evaluation of multiple output operations. The following year, we really follow up now with an actual aircraft test in which we used Boeing 737-700 provided by the Boeing Corporation. In which we looked at, weather to the cockpit and antenna performance. Again, on the same throughput, you can see that 737, it's being basically brought into a United Airlines hangar to accessorize it with the antennas which are shown there on the top right. Partners, and one of the great aspects about this work is it's also the partnership and working together in collaboration with other highly capable members of this team. We had Continental Airlines, Weather Services, ITT was back then providing great support and analysis on the data collection. We also had the FAA, of course, one of the great partnerships we've had. And also with Cleveland Port Authority. All of that comes together to enable this test. Without these type of partnerships, are really, really difficult to accomplish. this level of research and assessment. The following year, we moved on to do now an assessment of fixed video transport here. And what we're looking at is we're fortunate that during that time there was a new radar system being built at the airport. So it took advantage that there was still an older system in place, fully operational, non-commissioned, that we could run tests of WiMAX. So we took advantage of that. That's bottom picture, and that's the architecture, how we really send radar video to the NASA Glenn control room, and then we remote it back to the air traffic control tower for bringing it into the radar automation system. It was a successful test. We're able to see now the performance of the actual system in an interesting setting, because unlike voice, for instance, radar is a constant flow of information. So we were able to do that type of system. 2 years later, we look at the standard compliance, and now this is now closer to, in support of a lot of the standardization that's going on. We have Hitachi Corporation on board with their prototype system, in which now we're looking into now specific items such as network entry. How long does it take for the aircraft to acquire the network and associate with it? Traffic throughput rates, quality of service, mobility, long-term stability, of course, another important area that was assessed. So there's quite a bit of work going on in 2014. Next, please. And at the same time, there's other activities going on. I wanted to mention that because I think it's also important to realize that, the test bed is where we're going now after we have done quite a bit of investigation in the lab or simulation. And we did some simulation work as well. At Glenn, we do have a number of tools available to evaluate the system prior to sending it to a relevant environment. So in 2015, we understand that there's a need to evaluate the performance of the system, given that we have a co-sharing of the band. So internally, we set up the simulation capability in the systems to evaluate now the worldwide impact of WiMAX onto the satellite feeder links. It was a pretty interesting project. I remember working that in trying to understand many factors, including antenna orientation. We modeled 6,270 airports, and we're trying to understand, well, how do you know where antennas are going to be pointing it out? So there's a lot of dialogue internally to try to see how we come up with realistic assessment and evaluation. Look at 35 airports in the U.S., 15 in Europe, and you can see there's a long list of different areas around the world where we have airports. We looked, and an area that was interesting to find out, so where are those airports and what are the specifics of those airports, size, location, latitude, longitude, and everything, so we can do this assessment. Like the picture over there shows you the hotspot for the satellite, and I remember presenting this at RTTA a few years back. Take a look at the impact. So, same year, we also internally at NASA wanted to, we are researching, doing some research on smart maps. And it's a future evaluation of communication systems in these different stages of flight. So we utilize WiMAX in the evaluation of these future concepts. We used the technology to do a live virtual and constructive testing. Remember the information going to NASA Ames for evaluation of the system performance. And again, going out throughout the airport to send to California latitude and longitude position information of the vehicle, along with video. It was quite successful. The following year, we're looking at doing, which to me was a terrific trial, a great partnership with the FAA, in which we look at advanced aircraft access to swim, in essence, now bringing swim feeds to the cockpit. In this particular effort, we used WiMAX, of course, on Cleveland Hopkins Airport, and FAA installed WiMAX technology on their aircraft, and a couple of different antennas, in fact, as I recall, so that we can evaluate the performance of antenna location in different areas in different locations on the aircraft. This was a great collaboration with FAA and Hitachi. Of course, we used the Hitachi technology in NASA. What I want to also point out is that this was a terrific engagement also with air traffic control towers, Cleveland Hopkins. There was an opportunity to talk to controllers, look at taxi routes, and also look at staging, aircraft movement in times, et cetera. Quite a bit of collaboration with them. And during that trial, by the way, another, we had done a good number of tests at that time, individual, if you will, certain feeds. What we really wanted to do now is bringing together a larger set of feeds. So a big attempt here was to also now simulate a larger operation. So we brought in fixed data, simulated a surveillance system, and we added other types of data feeds to increase the loading on the system. The system, performed fantastically. We did have some areas in which coverage was not optimal, but given the circumstances of what the tests were and what we were intending to do, it all really worked out to the satisfaction of everybody that was involved in this campaign. Next, please. Actually, it's been, all this work really is not just verifying that the technology works and the tests really were successful and we executed accordingly, but it also has a target result and a means to really progress another activity. In this case, really has been the development of standards in both RTCA and ICAO. So there's some of the areas in which this activity, the WiMAX testing, supported the profile development, MOPS development, or minimum operation performance standards, user services requirements investigation and application survey. That was an activity in which we looked, tried to understand how would Port Authority use this system. It was surveys that we conducted. How do they see this particular technology assisting their operation? So we got a good chance to take a look at how they operate, what they do, what the needs are, so that we can, try to develop and tailor this technology to meet the needs of different stakeholders. And of course, we did all the validation testing for the standards, specifically for 23. For ICAO, again, the SARPS development, technical manual development, in which we support now the actual, how we could deploy an WiMAX system, in addition to system performance and measurements that were conducted, and how do they, support the standard. And finally, we took a look also at the satellite interference analysis that, I mentioned earlier. So, it's been a long journey at this point, and the question next is really, where else can WiMAX, support, the modernization progress of aeronautics and aviation in general? And there's a few areas I personally believe may gain from this type of technology, and that would be the first one is there's quite a bit of IoT devices out there. In essence, many devices are able to communicate or seek to communicate and send information. A lot of these devices are designed such that they can use millimeter wave, very short wavelength. So the penetration of such wave is really not very far. The powers are limited. So I believe that WiMAX is a great candidate to have to serve as a backbone, so that one can transport IoT device information, to a hub that may be distant, such that millimeter could not reach it. So the backbone operation, for instance, there's a graphic there in which it depicts WiMAX and how millimeter wave devices can access the backbone of WiMAX, and therefore use it as a means to transport a much greater distance. It could be used for baggage, it could be used for fueling information. So there's I believe a great opportunity to grow the use of the system beyond what its original intent. Urban air mobility, aerodrome critical service. This is a brand new area, and there's quite a bit of momentum. With urban air mobility is really, it's on-demand mobility. You're able to have a small size vehicle, probably electric, vertical takeoff and landing, transport a person in an urban area, no more than 30 to 60 miles, urban, suburban, let's call it that. In vertiports, still all it's work that's being done. What do they look like? Where are they located? How do they operate? As you can imagine, there's going to be a need for communications. WiMAX is already technology that has been proven for communications applications. So I think that there's great potential for its use in this area. Another area that I believe may be able to supplement the existing unmanned vehicle communications technology. Today they do have also allocations for unmanned or UAS, unmanned aircraft systems, but I believe that WiMAX could also help out and assist in video and in the taxiing of these aircraft while on the ground. I don't know that there has been any tests in this particular area or development, but I think that given that this is a surface technology, it should be able to complement and supplement unmanned vehicles operating on the airport surface. And then last area that came to mind is, pretty much along the lines of autonomous vehicles. I believe that if properly architected, the WiMAX technology could be also used to enable autonomous taxi operations on the airport surface, akin to what's being thought of today on autonomous vehicles. If you know, if you have bad weather or instances where mobility on the airport surface is almost prohibited due to visibility, for example, then this type of technology should be able to aid and support, moving vehicles on the airport surface autonomously. So, with that, I conclude this presentation, and I do want to thank the WiMAX Forum for giving me the opportunity to talk about something that that I really enjoy. Airport wireless communications, and I've had a lot of work in this area. And to Declan, I appreciate all the work that's going on by the forum and the dedication to the technology and seeing its growth and implementation worldwide. And again, this has been a big partnership with industry and government. I don't think we could have progressed it to where we have it today if it wasn't for all that dedication and hard work. So with that, Declan, I'll hand it back to you. Thank you.
Thank you, Raphael. I think it's interesting when particularly as we all sit kind of in lockdown in 2020, you can kind of lose perspective sometimes on where we were and potentially where we're going, right? And for me, it's a thrill, actually. It's rejuvenating to you talk about the kind of intense effort and creative and innovative thinking that's been going on for 15 years around the development of WiMAX and the kind of rich application set around it. Starting at NASA Glenn with, how long does it take to get network entry? Do we have a stable link? To finding ourselves in 2020 with 50 plus airports around the world with WiMAX systems. Yeah. And then you kind of, the work doesn't end. You start talking about, autonomous taxi, UAV, urban air mobility, and all these other, I think these are absolute overlap applications because you've got a licensed broadband wireless system that's being deployed, right? That's been blessed by ICAO, standardized, et cetera. So I think, as they used to say, the future's so bright and where it shows. I think we're not being Pollyannish about it, but I think we're in a good spot. As soon as we get out of 2020, I think a lot of us think this is a year that we'll be happy to see in the rear view. I'm very optimistic and interested about what the next 10 years will hold as well. So ours is thank you again, Raphael. The WiMAX Forum is a not-for-profit. We're sustained by our membership. We were created really to develop technical profiles associated with the WiMAX telecommunications standard. But 99% of what we do now is really leveraging the work for the aviation industry, leveraging the IEEE standard and the associated WiMAX profile, which we sort of manage. We're not a standards development organization, but we manage the technical profile, meaning we evangelize for it. We explain to regulators, manufacturers, and users the application set around WiMAX, how others are using it. We bring together the community, generally in face-to-face settings at conferences or either other people's conferences or conferences we host to talk about the application set, the vendor, form, fit, function set, and all that. Another key aspect of what we do in our work is spectrum work. So we're involved directly with national radio authorities on the associated spectrum rules around 5091, 5150, the set aside, if you will, for WiMAX internationally. So that takes a lot of our time. And then as well, we do a lot of work on vendor certification. So if a Siemens or Leonardo or a Honeywell for that matter want to bring quote unquote WiMAX products to market, we certify those products at an independent lab, and so that users will have the comfort of knowing that what they're actually purchasing has been looked at and independently verified to be compliant with the standard, which ultimately is a requirement because this equipment has got to interoperate with other manufacturers' equipment around the world. So we talked a lot about in our prior presentations, and I think Raphael alluded to it, there are a number of benefits for it, which is why WiMAX is being taken up and why it was selected, really, in terms of, improved air traffic management. Ultimately, it's about, safety, increasing safety, increasing efficiency, regularity of flight, and we're on the very beginning of identifying suitable applications that feed into that do certainly highlight safety, but increase operational throughput and other efficiencies. Next slide. The nice thing about WiMAX is that you can have a phased deployment. You can begin with a very, very modest trial with 1, 2 base stations and 10 devices. Again, just to satisfy yourself as a user that the connection can be stable, ease of installation, ease of management, et cetera. And then as you grow applications and demand, you can add more coverage, more equipment, et cetera, et cetera. And that is certainly what we are seeing in terms of take-up across those 50 airports in 10, 20 countries that have now installed WiMAX space at the various airports. And it was, early adopters were testing, then application development, and now kind of layering into those networks additional applications, additional revenue-generating applications, and/or cost-saving or safety-enhancing applications. It's a pretty exciting roadmap in terms of where we've been. You look back to 2009 with NASA Glenn, and Raphael was involved in one of those very, very first early deployments over 11 years ago. And then as we look to 2021, we really are accelerating into a more dense airport model worldwide, which is pretty exciting. Next slide. And yeah, as I say, the next is down. So WiMAX was envisioned as the next generation communications technology alongside SATCOM and LDAX, and we can comfortably say it is here. And certainly that is why it is considered a candidate technology in support of urban air mobility, unmanned air systems, et cetera, et cetera. And so that's a conversation that is just beginning, both in the United States and elsewhere, but I think it's one that's rich in possibility. So again, if you have any questions or comments, please shoot us a note. Either Alessandro or myself, we have lots of member companies that kind of really make or break this industry. It's a pleasure working with everyone, and Raphael, you couldn't say it better. It's industry and private sector and governmental partnerships that really made this work over the last 15 years, and that is why we've had the success we've had, and that's why I think we'll continue to have the success. So, again, before I close out, I want to thank you, Raphael, and all the folks at NASA and the vendor partners that kind of helped you in those early days. I want to thank you personally for the work you have done and will continue to do. And I'm looking forward to seeing you at a conference soon when they allow us back in the airplanes again. And here's kind of a slide of the various companies that have participated not only in our virtual series, but are kind of stalwarts in the WiMAX system. And here you've got users, manufacturers, regulators, et cetera, all of whom we count in the WiMAX family. So without further ado, I'm going to close the call. And once again, thank you very, very much, Raphael.